it's a mercury arc rectifier. And it's been disconnected and it's DC 120 to 20 plus 40 amps and AC 30 120. Glows blue greenish. It's beautiful all inside. They still use those things for the subway in New York in some places to make the AC current into DC current. It's DC voltage. And the way it was done is that you had the AC coming in on each of the sides and the DC would come out on the top. And this would start the actual reaction. So in fact, it's backward. It's supposed to be on the other side. When you hold it
upside down?
Yeah, turn it upside down. Just be careful not to drop it. Just go slowly so the mercury doesn't slam in there. Okay, okay, see that? Okay, let it go like that. You see, this is the starting electrode. And you start the arc inside, and then after that, it's a little bit like a mercury discharge lamp. And when the glues discharge start, then you could put the AC in, and the DC would come out at the end. Slowly in the middle there. Yeah.
This side or the other way?
Like that. No, like that. Perfect. Now you see the way it fits?
Yep.
Bring at the bottom there. Okay. Okay. And at the time to take any... It was there because see, DC is there. And it says probably was hooked up to one of those.
So now it was charging that machine in DC current?
Yeah, because DC is
batteries. Because of batteries, right, of course, yeah.
This was what is the diode today? This was the ancestor of the diode with the rectifier. The rectifier, the whole time, there was only one way to do it, and it was with tubes. Today they do it with semiconductors. No, the same thing today could be replaced with a semiconductor about that big, about a couple of them, that's all. But at the time, the only way to do it was with a mercury discharge lamp. Okay. That one is on a gimbal, okay? Okay, you see that? It's on gimbal, okay? So what they did, okay? You see in the front, there's a knob there, okay? You see the knob?
Yep.
They turn it up, and what happened is that it short-circuit the mercury. It bounced. It doesn't bounce, but it wiggles back and forth. I won't touch it too much, but it made the mercury contact there and created a short. And that short, when you came back, it would start the arc. And it's called the initiator striking electrode. And then after that, when the arc was started up, then the machine. This is why there is a lever on the top here, and it says start. It says starting switch, and there is the running switch. And some of those balls are huge. I mean, some in power station they use them in an old-time power station. They had some made of glass that were almost like 3 or 4 feet in diameter. And I mean almost 6 or 7 feet high on a gimbal like that. But they would supply like megawatts of power. No? This is a small unit. Exactly like that. This is the input.
That's the input.
Yeah, this is the power input there. And the DC was going, the DC is on this side. This is the male part of the connection to the baker's car, electric car, and you could see that there's the positive terminal there, and the negative is in between that recess inside, and it was there for charging the batteries on the car. This is probably a choke, a reactor choke. Okay, this is the striking electrode. Okay, this is what's called a probe start. Okay, this is the DC stage output, AC one side and AC on the other side, half wave AC on the other side. Running switch. This is running switch, starting switch. Limit current.
That's a reactance choke?
Yeah, to limit current.
At the bottom.
Yeah.
Steve?
It's a resistor grid, and I don't know if, because I'm trying, okay, there's a name plate here, because I want to be gentle with it. I don't want to, see there is a
that's a resistor grid?
Yeah, and there is a rating on it, but I don't want to scratch it too much because it removes the importance of the part if you try to scratch it.